question arises about the use of GE Slimline breakers after an inspector suggested replacing them. The concern was that using these breakers could lead to maxing out the panel and utilizing all 40 spaces. However, the National Electrical Code, Section 384.15, allows for a maximum of 42 spaces. The panel box indicated it was designed for 40 spaces with half-inch breakers or 20 spaces with 1-inch breakers. The question posed is whether there have been past issues with slimline breakers causing fires or other problems. Research indicates that there's no evidence of past problems with GE Slimline breakers catching fire. They are still being manufactured and sold. These breakers are designed to occupy half the space of a standard 1-inch wide breaker, which can be advantageous when panel space is limited. It is possible that the inspector has had negative experiences with slimline breakers or is unfamiliar with them. If there are concerns about the inspector's decision, ask for more information or the specific code section that supports their stance. The ultimate decision of whether to replace the slimline breakers rests with the individual. If replacement is chosen, using GE breakers of the same amperage and type is recommended. This will ensure that the panel is properly protected. The following points should be considered when evaluating the use of slimline breakers. Firstly, verify the panel's listing and labeling. The panel's listing will specify the types and sizes of breakers that are approved for use in that particular panel. Using breakers that are not listed for the panel can void the warranty and may create a safety hazard. Secondly, check the National Electrical Code (NEC) requirements. The NEC provides guidelines for the installation and use of electrical equipment, including circuit breakers. Ensure that the installation of the slimline breakers complies with all applicable NEC requirements. Thirdly, consider the load calculations. Before adding or replacing any circuit breakers, perform a load calculation to ensure that the panel has sufficient capacity to handle the additional load. Overloading the panel can lead to overheating and potentially a fire. Fourthly, inspect the breakers for damage. Before installing any circuit breakers, inspect them for any signs of damage, such as cracks, broken pieces, or corrosion. Damaged breakers should not be used. Fifthly, ensure proper installation. Circuit breakers should be installed according to the manufacturer's instructions and should be properly secured in the panel. Loose or improperly installed breakers can create a safety hazard. Sixthly, test the breakers. After installation, test the circuit breakers to ensure that they are functioning properly. This can be done using a circuit breaker tester. Seventhly, consider professional advice. If there are any doubts or concerns about the use of slimline breakers, consult with a qualified electrician. They can provide expert advice and ensure that the installation is safe and code compliant. When evaluating the safety of electrical components like circuit breakers, several factors come into play. Firstly, the design and manufacturing process is crucial. Reputable manufacturers adhere to strict quality control standards to ensure their products meet safety requirements. Look for certifications from organizations like Underwriters Laboratories, all which indicate that the product has been tested and meets established safety standards. Secondly, the materials used in the construction of circuit breakers play a significant role. High-quality materials are more resistant to heat, corrosion, and other environmental factors that can degrade performance and lead to failure. Thirdly, proper installation is paramount. Even the best circuit breaker can be a safety hazard if it is not installed correctly. Follow the manufacturer's instructions carefully and ensure that all connections are tight and secure. Fourthly, regular maintenance and inspection are essential. Circuit breakers should be periodically inspected for signs of damage such as cracks, discoloration, or loose connections. Any damaged breaker should be replaced immediately. Fifthly, understanding the limitations of circuit breakers is important. Circuit breakers are designed to protect against overloads and short circuits, but they are not foolproof. They can fail under certain conditions, such as extreme heat or prolonged exposure to high currents. Sixthly, using the correct type of circuit breaker for the application is critical. Different types of circuit breakers are designed for different types of circuits and loads. Using the wrong type of breaker can lead to nuisance tripping or, in more serious cases, failure to protect the circuit. Seventhly, staying informed about safety recalls and alerts is crucial. Manufacturers and regulatory agencies issue recalls and alerts when safety issues are discovered with electrical products. Staying informed about these recalls can help you identify and address potential hazards. Additionally, consider the specific application and environment in which the circuit breakers will be used. For example, circuit breakers used in harsh environments such as those with high humidity or corrosive atmospheres may require special protection or construction. Also, consider the potential for future expansion or changes to the electrical system. Choosing circuit breakers with sufficient capacity and flexibility can help avoid problems down the road. Understanding the different types of circuit breakers and their applications is essential for ensuring electrical safety. Firstly, standard thermal-magnetic circuit breakers are the most common type. They use a bimetallic strip and an electromagnet to trip the breaker in response to overloads and short circuits. Secondly, ground fault circuit interrupters, GFCI, are designed to protect against ground faults which can cause electric shock. They are commonly used in bathrooms, kitchens, and other areas where water is present. Thirdly, arc fault circuit interrupters, or SI, are designed to protect against arc faults, which can cause fires. They are required in many areas of the home, such as bedrooms and living rooms. Fourthly, high current circuit breakers are used in high current applications, such as main service panels and industrial equipment. Fifthly, molded case circuit breakers are used in commercial and industrial applications. They are available in a variety of sizes and ratings. Sixthly, miniature circuit breakers, MCB, are used in residential and light commercial applications. They are smaller than molded case circuit breakers and are typically used in panel boards. Seventhly, solid-state circuit breakers use electronic components to detect overloads and short circuits. They offer faster response times and more precise protection than traditional thermal-magnetic breakers. Understanding the different ratings and characteristics of circuit breakers is also crucial. Firstly, amperage rating is the maximum amount of current that the circuit breaker can carry without tripping. Secondly, voltage rating is the maximum voltage that the circuit breaker can safely handle. Thirdly, interrupting rating is the maximum amount of fault current that the circuit breaker can safely interrupt. Fourthly, trip curve is the relationship between the amount of current and the time it takes for the circuit breaker to trip. Fifthly, series rating is the maximum amount of fault current that a series combination of circuit breakers can safely interrupt. It is important to select circuit breakers with appropriate ratings for the application to ensure proper protection. When dealing with electrical inspections and potential code violations, consider these factors. Firstly, understand the local electrical codes. Electrical codes vary from jurisdiction to jurisdiction, so it is important to understand the specific codes that apply to your area. Secondly, communicate with the inspector. If you have any questions or concerns about the inspector's findings, don't hesitate to ask for clarification. Thirdly, document everything. Keep records of all electrical work that is performed, including permits, inspections, and test results. Fourthly, be prepared to make corrections. If the inspector identifies any code violations, be prepared to make the necessary corrections in a timely manner. Fifthly, consider hiring a qualified electrician. If you are not comfortable performing electrical work yourself, hire a qualified electrician to do the job. Sixthly, appeal the decision. If you disagree with the inspector's findings, you may have the right to appeal the decision. Seventhly, stay informed. Stay up to date on the latest electrical codes and safety standards. The National Electrical Code, NEC, is updated every 3 years, so it is important to stay current on the latest changes. Additionally, consider the following points when evaluating the use of slimline breakers in a particular application. Firstly, the panel's physical space constraints. Slimline breakers can be useful in panels where space is limited, but they may not be necessary in panels with ample space. Secondly, the overall load in the panel. Ensure that the panel has sufficient capacity to handle the additional load from the slimline breakers. Thirdly, the type of loads being served. Some loads, such as those with high inrush currents, may require the use of standard size breakers. Fourthly, the potential for future expansion. Consider whether the use of slimline breakers will limit the panel's ability to accommodate future expansion. Fifthly, the availability of replacement breakers. Ensure that replacement slimline breakers are readily available in case they are needed in the future. Sixthly, the cost of the breakers. Slimline breakers may be more expensive than standard size breakers. Seventhly, the aesthetic appearance of the panel. Some people prefer the look of a panel with all standard size breakers. By carefully considering these factors, you can make an informed decision about whether or not to use slimline breakers in a particular application. Remember that electrical work can be dangerous, so it is always best to consult with a qualified electrician if you have any questions or concerns. They can help you ensure that your electrical system is safe and code compliant. The concerns raised by the inspector could stem from several factors, including local amendments to the NEC that restrict the use of tandem or slimline breakers, even if the panel is rated for them. These restrictions are often in place to ensure adequate space for heat dissipation and to prevent overloading of the panel. Another factor could be misapplication. Even though the breakers themselves may not have a history of problems, using them in a manner not intended by the manufacturer or the NEC can create a hazardous situation. For example, if the panel is not properly ventilated, using too many slimline breakers could lead to overheating. The inspector's experience also plays a role. They may have encountered situations where the use of slimline breakers contributed to electrical problems, even if the breakers themselves were not the direct cause. This experience could lead them to be more cautious about their use. Ultimately, the decision of whether to require the replacement of the slimline breakers is up to the inspector, based on their interpretation of the local codes and their assessment of the specific installation. However, you have the right to ask for clarification and to appeal the decision if you believe it is not justified. In your appeal, you can present the information you have gathered, including the NEC section that allows for 42 spaces and the manufacturer's specifications for the panel. You can also ask the inspector to provide specific reasons for their concern, such as evidence of overheating or code violations. If you are still not satisfied with the inspector's decision, you can consult with a qualified electrical engineer or another electrical inspector for a second opinion. Remember that the goal of electrical inspections is to ensure safety and compliance with applicable codes. While it is important to protect your rights, it is also important to address any legitimate safety concerns. Working with the inspector to find a solution that meets both your needs and the requirements of the electrical code is the best approach. The National Electrical Code is a comprehensive set of standards for electrical wiring and equipment in the United States. It is updated every 3 years by the National Fire Protection Association, NFPA. The NEC is not law, but it is widely adopted by states and local jurisdictions, making it the de facto standard for electrical safety. The NEC covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. It is essential for electricians, electrical inspectors, and anyone involved in electrical work to be familiar with the NEC. The NEC is organized into chapters, articles, and sections. Each section contains specific requirements for electrical installations. The NEC also includes numerous tables and figures that provide additional guidance. The NEC is a complex document and it can be challenging to interpret. However, there are many resources available to help, including training courses, online forums, and publications. It is important to stay up to date on the latest changes to the NEC to ensure that your electrical installations are safe and code compliant. Failure to comply with the NEC can result in fines, penalties, and even legal action. In addition to the NEC, there may be local electrical codes that apply to your area. These local codes may be more restrictive than the NEC. It is important to be aware of any local codes that apply to your electrical installations. Electrical inspections are conducted to ensure that electrical installations are safe and code compliant. Electrical inspectors are typically employed by state or local jurisdictions. They are responsible for inspecting electrical work to ensure that it meets the requirements of the NEC and local codes. Electrical inspections are typically required for new construction, renovations, and electrical repairs. The inspection process usually involves a visual inspection of the electrical system, as well as testing of certain components. If the inspector finds any code violations, they will issue a notice of violation. The homeowner or contractor is then responsible for correcting the violations. Once the violations have been corrected, the inspector will conduct a re-inspection to verify that the work has been completed properly. Passing an electrical inspection is essential for obtaining a certificate of occupancy for new construction. It is also important for ensuring the safety of your home and family. The process of researching electrical products and their safety ratings can be approached in several ways. Firstly, check for certifications from recognized testing laboratories such as Underwriters Laboratories, UL, or Intertek et al. These certifications indicate that the product has been tested and meets specific safety standards. Secondly, consult the manufacturer's website or product documentation for safety information and specifications. Look for details on the product's intended use, limitations, and any safety precautions. Thirdly, read reviews and ratings from other consumers or industry professionals. This can provide valuable insights into the product's performance and reliability. Fourthly, search for recalls or safety alerts issued by regulatory agencies such as the Consumer Product Safety Commission, CPSC. This can help you identify any potential hazards associated with the product. Fifthly, compare products from different manufacturers to see how they stack up in terms of safety features and ratings. Sixthly, consider the product's warranty and return policy. A reputable manufacturer will typically offer a warranty that covers defects in materials and workmanship. Seventhly, consult with a qualified electrician or electrical engineer for expert advice on selecting the right products for your application. They can help you assess your needs and recommend products that meet your safety requirements. Additionally, consider the following factors when researching electrical products. Firstly, the product's intended use. Make sure the product is designed for the specific application you have in mind. Secondly, the product's voltage and amperage ratings. Ensure that the product is compatible with your electrical system. Thirdly, the product's environmental ratings. If the product will be used outdoors or in a harsh environment, make sure it is rated for those conditions. Fourthly, the product's ease of installation. Choose products that are easy to install and maintain. Fifthly, the product's cost. Compare prices from different suppliers to find the best deal. Sixthly, the product's availability. Make sure the product is readily available in case you need to replace it in the future. Seventhly, the product's reputation. Choose products from reputable manufacturers with a track record of safety and reliability. By carefully researching electrical products and their safety ratings, you can minimize the risk of electrical hazards and ensure the safety of your home and family.